Okay, so students, let's continue with the redox reaction. So in the redox reaction in the previous class, we have seen what are the reduction, oxidation reaction and how they are simultaneously happening in a chemical reaction. Also, we have seen that how to identify a reduction and oxidation reaction in a chemical reaction. Okay. Now, moving further in this chapter, the next topic which we are going to see here is the oxidation number and nomenclature of the compounds. Oxidation number and the nomenclature of the compounds. Okay. Oxidation number and nomenclature of compounds. So in the previous time, okay, in the earlier times, the compounds which were having two ions, okay, they were named by using the suffix OUS or the suffix IC. Okay, these two suffixes were used in order to represent the elements which were having two different ionic states. Okay, two different oxidation states were there. Then they were represented by using this particular two different suffix there. For example, if copper, it is possessing 1 plus charge. Okay, so it means that its oxidation state is +1. Then it was represented using the suffix OUS, that is cuprous. Similarly, if copper is having 2 plus charge, it means that its oxidation state is +2. Then IC is the suffix which is used out here. Then the name of the copper will become cupric. Okay, so this kind of rule was used previously. Means that the lower oxidation state, then the suffix will be used there, it will be OUS, and the higher oxidation state, the suffix will be used there is the IC, that is cupric. Okay, so after some time, Albert Stock, okay, he has proposed, Albert Stock has proposed a new system for naming using the oxidation state, and that naming system is termed as Stock system. Stock system, and in this we use the Roman number, okay, the Roman number representation, the Roman number representation just after the element showing its oxidation state or oxidation number. Okay, so nowadays we are using the rules such as Cu2O. For naming this compound, we will use the rule of the Stock system. According to that, the name will be copper. Here, oxidation for state for copper is 1. So, representing it by a Roman number, oxide, copper 1 oxide. The name will be copper 1 oxide. Similarly, SNO, that is tin oxide. Okay. So, here the oxidation state for tin is +2. So, the name will be tin 2 oxide. Okay, for ferrous, if I am taking FeCl2, then it will be iron 2 chloride. But for FeCl3, I will use the letter 3 here, iron 3 chloride. Okay, so it is creating more transparency as comparison to that of the previous method we were using. Okay, so for higher valencies also, we can, for higher oxidation state, we can also show here, such as Mn2O7. Here magnesium is having the oxidation state of 7, so it can be easily shown up here, manganese manganese, manganese, manganese 7 oxide. The name will be manganese 7 oxide. Okay. For potassium, sorry, for the chromium, here in the potassium dichromate it is potassium dichromate, and the chromate here is having the oxidation state of 6. Okay, so like this higher oxidation states element can also be represented by using this stock system. Okay, stock system cannot be used for the non-metals. Okay, it cannot be used for the non-metals. Now let's see the types of redox reaction. Okay, let's talk about the types of redox reactions. So in that, the first type is the combination reaction. Combination reaction. So the definition for combination reaction, you have studied this in your class 10th also. The chemical reaction, the chemical reaction in which two or more substances two or more substances, these substances can be either elements or compounds, okay, are combined to form a single substance, a single substance are called combination reaction, are called combination reaction. For example, here we can take the example for the combination reaction as when carbon, which is solid, is reacting with oxygen, which is gaseous, on heating, it will produce carbon dioxide. So here, on the basis of the redox reaction, if I am talking about the redox reaction here, okay, means the reduction and oxidation here, then the carbon solid, it means its oxidation state is 0. Oxygen O2 is there, it means the oxidation state for diatomic molecule will also be 0 here. But when we are considering here for the atom, for the molecule of carbon dioxide, then here the carbon is having oxidation state of +4 and oxygen is having oxidation state of -2 here. So it means that for carbon the oxidation number has been increased. It means that oxidation in the case of carbon is being seen here, while in the case of oxidation for, while in the case of oxygen, we will see that from 0 to -2 it has been decreased. It means that here the reduction is being seen out. Okay, reduction is being seen out here in the case of the oxygen. Next, number 2, decomposition reaction. Decomposition reaction. Okay, so decomposition reaction, the chemical reaction in which the chemical reaction in which a compound breaks, a compound breaks into two or more simple substances are decomposition reaction, or decomposition reaction. For example, here the example can be 2H2O liquid, it will get decomposed to 2H2 gas plus O2 gas. Okay, so here the oxidation state for hydrogen in the molecule of water will be +1, For oxygen it will be -2. So here in the case of hydrogen it has become 0, and in the case of oxygen it has become 0. Okay, so here we will observe that in case of hydrogen the oxidation state has decreased. Okay, it has been decreased from +1 to 0. So it means that in the case of hydrogen reduction has been occurred out here, and in the case of oxygen we will observe that from -2 it has increased to 0. So it means that oxidation has been occurred out. Okay, so this is the example for the decomposition reaction. Next is the displacement reaction. Displacement reaction. The chemical reaction in which one ion in a compound, the chemical reaction in which one ion in a compound is replaced by an ion of other element are called displacement reaction. Are called displacement reaction. Okay, so here in the case of displacement reaction there are two different types of displacement reaction. The first is the metal displacement reaction. Metal displacement reaction, where a more reactive metal will displace a lesser reactive metal. Okay, a more reactive metal will displace a lesser reactive metal from its salt solution. Okay, then it will be termed as metal displacement reaction. In here we can take an example for copper sulfate in aqueous solution is displacing zinc solid. So here copper solid and zinc sulfate will be formed out. Okay, so copper sulfate, in that copper is having +2 charge. Okay, +2 oxidation state, and sulfate is having -2 oxidation state. +2 oxidation state, -2 oxidation state. While zinc is a solid, so it is and it is a monatomic solid, so it will be having 0 charge here. Similarly, the oxidation state for copper here is 0 in the product side, and zinc is having +2 and sulfate is having -2. So here we can observe that sulfate has no change in its oxidation state. The change here, it has been observed that the copper's oxidation state has decreased out here, while the zinc's oxidation state has increased out here. Okay, so we can say that zinc has oxidized while copper has been reduced. Okay, copper has been reduced. So this is the metal displacement reaction, where we have seen that the oxidation and reduction of the copper and zinc has been done, and copper has been displaced by zinc in its salt compound. Okay, next is the nickel sulfate in aqueous solution plus 2 cobalt solid is been displaced by cobalt sulfate and nickel solid. So here we will see that nickel is having how much charge? It is having +2 here. Okay, +2 state, oxidation state. Sulfur is having how much? Sulfur is having, if it is having -2, then +2 -2 0. So it will be having how much charge? It will be having +6. Okay, +6. Similarly, here in cobalt is a monoatomic compound, so it will be having 0 charge. Okay, so here the compound which is formed of cobalt sulfate, it will be having +2 +6 -2. Here nickel will be having zero charge. Okay, so then on comparing here we will see that sulfate ion has not changed its oxidation state. Only the cobalt and nickel has been changed out here. The oxidation state for cobalt and nickel has been changed. Here the cobalt's oxidation state has increased while nickel's oxidation state has decreased. So it means that oxidation oxidation and second is the reduction. Okay, oxidation and reduction, two has been two different things we have observed here, that when a cobalt metal is displacing the nickel metal. Now let's see the next type of displacement reaction, that is non metal displacement reaction. Non-metal displacement reaction. So here in the non-metal displacement reaction we will observe that all alkali metals and some other alkaline earth metals which are good reducing agent will displace hydrogen from the cold water. Okay, means highly reactive metals will displace water from the from the hydrogen from the cold water. Okay, for example, Na when reacted with water, so here 2NaOH will be formed out here plus H2 gas will be released. Okay, so here Na is in singular form, is in its monoatomic form, it is having oxidation state of 0, hydrogen plus 1, oxygen minus 2, here sodium plus 1, oxygen minus 2, hydrogen plus 1, and hydrogen dihydrogen is having 0 charge. Okay, so here we can see that hydrogen's oxidation state has not been changed, but hydrogen's oxidation state in one of the case here has been reduced from plus 1 to 0, and the nitrogen sodium's oxidation state has been increased out here from 0 to plus 1. So here we will say that sodium has undergone oxidation while the hydrogen has undergone reduction to form hydrogen gas. Okay, next, when less active metals, okay, when less active metals such as aluminium, magnesium, iron, okay, all these reacts with the water, they react with generally with the hot water. Okay, they will react with the hot water. So for taking the example here, magnesium, so magnesium will react with hot water, not with cold water. Okay, it will react with the hot water and it will form magnesium hydroxide plus H2 gas. 0, magnesium plus 2, oxygen minus 2 plus, here oxygen, hydrogen plus 1, oxygen minus 2, magnesium 0. Okay, so here we will see that magnesium's oxidation state has increased out here, hydrogen's oxidation state has decreased out here. So here in the formation of hydrogen gas, reduction is been occurred out here. While in the case of magnesium, due to increase in the oxidation state, we will say that here oxidation has been carried out. Metals are reacting with the the metals which are not reacting with cold water, but they can displace the hydrogen from acids, from the hydrogen acids. Okay, for example, zinc, it can displace hydrogen from the acidic dilute acids. Okay, they can displace the hydrogen from the dilute acid to form zinc chloride and hydrogen gas. Here zinc is having 0 charge, hydrogen is having plus 1, chloride is having minus 1. Here zinc is having plus 2, chloride is having minus 1, and hydrogen is having 0. So here we will see that chloride's no, oxidation state is same, minus 1, while the oxidation state for hydrogen has been decreased and oxidation state for zinc has been increased out here. So oxidation for zinc and reduction for the hydrogen is been observed out here. So these are some of the reactions which are showing the displacement of non-metals, okay, which are showing the displacement of non-metals with the metals, and they are also type of redox reaction. The next type of redox reaction which we are going to discuss here, it is the disproportionation reaction. Disproportionation reaction. Disproportionation reaction. Okay. So in the disproportionation reaction, the reaction in which an element, the reaction in which the element the element in one oxidation state, is simultaneously simultaneously oxidized and reduced is called a disproportionation reaction. Proportionation reaction. Okay. So for example, we can see out here for hydrogen peroxide. Okay, hydrogen peroxide. So when hydrogen peroxide decomposes, it forms water and oxygen gas. So here for hydrogen, in the hydrogen peroxide, we will see that the oxygen is having -1 oxidation state and hydrogen is having +1 oxidation state. In the case of water, the oxidation state for hydrogen is +1, oxygen is -2, and in the case of O2 it is 0. So here in the both the cases we will observe that oxygen has been undergone both the oxidation and reduction. Okay. In the case of water, we will see that the oxidation state of the oxygen has been decreased there. It means that it has been reduced out here. And in the case of the oxygen gas, the oxidation state of the oxygen has been increased here. It means that oxidation of the oxygen has been gone out. So this type of reaction in which only one metal which is acquiring a single oxidation state is been simultaneously reduced and oxidized, that type of reactions is termed as disproportionation reaction. Okay, one more example here we can see for phosphorus. When it is reacted with hydroxide ion in any aqueous solution, it means it is been reacted with the alkali here. Okay, then here we will see that the formation of phosphine gas is taken place and formation of phosphorus acid has been taken place. Okay, so here phosphorus has undergone two different reactions here. In the first, in the case of phosphine, here we will see that phosphorus is having -3 oxidation state. While in the case of phosphorus acid, here the phosphorus is having oxidation state of +1. Okay, so here from 0, its oxidation state has decreased out here. So it means that reduction has been gone in the case of phosphine for phosphorus, and in the case of phosphorus acid the oxidation state has been increased from 0 to +1. It means that oxidation has been occurred out. Okay, so this is the reaction for the phosphorus where disproportionation has been seen out. Okay, so these are the reaction where disproportionation is being seen. Now moving further, we are going to discuss about the balancing of the chemical reaction. Okay, so balancing of the chemical reaction we will discuss in the next class. For today's class we have seen all the types of redox reaction, in which we have seen the combination, decomposition, then displacement reaction, and after that disproportionation reaction. Also we have discussed about the nomenclature related to the oxidation number. So in the next class we are going to see the balancing of the chemical equation on the basis of the redox reaction. Okay, so two different methods are there. First method is your oxidation number method. Okay, and the second method is your ion electron method. Ion electron method. So we will discuss about both these two methods, that is oxidation method or ion electron method, also termed as half equation method. Half equation method. So for today I am closing the class here only. Thank you.